What's up, guys? Welcome back to Vanover Machine and Repair, and we have a very exciting video today. We have a massive job behind me. Two large 3,000-pound impellers that need to be machined, and we're going to be machining them on the brand new lathe. Let me bring you in close and give you some of the details. Taking a closer look at these parts. This impeller is about 7 feet long. The center section here is about 26 inches in diameter, and it has two bronze impellers on each end of the washer. Now, the main issue with this is that these bronze impellers have actually worn into this center washer, as I'm going to call it. So the job is to disassemble this and to remachine both flats on this center washer. And then there's two end caps that go on either end that we also need to machine flat. So this will be a little bit challenging to disassemble because we don't have a hydraulic press that is horizontal, but we're going to use some trickery and see what we can do to get it apart. Here is a closer look at these end caps. Now, the center washer is more worn than these, and we'll take a look at that once we get it disassembled. But this gives you an idea of what we're working with. This end cap is worse. We have a step here that we're trying to machine out. We do have some pitting that is not going to completely machine out, but the customer is aware of that. The biggest challenge for machining these is gripping them because this hole is eccentric to the OD. We can't grab from the middle, so we'll need to grab this from the outside. And with this being 26 inches, that's going to be fairly interesting. But aside from that, once we can figure that out, this will be fairly straightforward. Just some simple facing work we need to do. Before we disassemble this, we're going to mark each component. That way we know that we're putting this back together in a similar place. So we're just going to drill a hole. Just a minor mark so we know that this is number one. We'll do number one, and then the other one we'll do number two, number two, number two, so we can make sure these go back together in the same orientation. All right, on the off chance we're gonna get lucky, I'm just gonna try to pry this first impeller off gently. And it does come off in this direction we're prying. I personally don't think it's going to come off this way, but before you go extreme, you always start simple. All right, that's not going anywhere. I didn't think it would. This center part does rotate, so I think getting this off will be a little bit easier. But I think these are going to be a little bit more challenging, which is what I anticipated. What I'm going to do is we have an eye hook that we're going to thread into the other end, and we're going to stand this on end or on an angle, and we're going to warm these up because they're bronze. They should expand at a pretty high rate compared to the steel and hopefully grow in size, and then maybe they'll just fall right off, or we can very gently slide them off. All right, we got a little bit of a change of plan. I was throwing this idea past Daniel. He's here working on the Lucas. He thought it might be better to try to pull these off using a port power as opposed to hanging these up, because we really don't have anything to hang them from here in the shop. I was gonna suspend them with the forklift, which would have worked for a short time, but we're gonna give this a try. So I fabbed up a couple of these angle mounts. We got a piece of rubber here, and we got our sawhorses. So we're gonna get this rigged up, set down on these V-blocks, and we'll see if we can pull off the plates. Also, I think these plates might be stainless. Daniel looked at them. They're not magnetic, but looking at the color a little more, I don't think they're bronze. So let's see what we can get on with getting these removed. $11.78. First attempt. Here's what we got set up. I welded these guys up. We have 1/2 inch plate, 1 inch plate, 1 inch hole, 3/4 inch D-ring. If this isn't gonna work, I might get some 1 inch. Got some chain, and we got a 30-ton porta-power. I got a 100-ton. We're gonna start here. We're gonna take it easy, see how we look. This might be a flex point here. We'll see. We don't wanna crack anything. We're gonna take it slow, see how tight this thing is. Okay. Oh, it moved, I think. Yeah, it did move. It did move. Cool. It did move. We have 7/8. Well, guys, we're back with a different setup. We did get this to move with the previous setup, but I have the lucky honor to have someone here, Daniel, working on the boring mill. So he had some different ideas about the way that I was doing this, and he thought that a setup like this would be safer and more efficient. And so we spent some time, did some custom tooling. The first thing is, instead of pressing off this housing, we're actually now pulling from whatever we want to call this impeller. And we have 2 fish plates on either side. These are 1/2 inch. And the nice thing about this is that other one has a 5/8 gap, and there is a gap between here. So we're using that to our advantage to come in here, and we're using these basically as bearing knives. And then on the front, we have another 1/2 inch plate, and we've tied this together with 3/4 tin rod, which is good because on the back side, we can use couplers and make it longer or shorter using 3/4 tin fixturing for the larger milling machine. So that's really nice. Got some nice 3/4 eye hooks. And what this is doing is this is allowing us to, one, not press on this, but more importantly, to pull on the actual impeller itself and to pull more on the center line of the part. So in theory, there should be less deflection, less risk of damage. There it is, it's tightened up. There still is a fair amount of force on that. Definitely moved there. Our front plates are a little, maybe I'll weld a brace on the back. All right, we got some reinforcement, a backbone here. We're gonna see if that makes a difference and go from there. It's been about a day and we've changed our setup since the last shot. Now we were able to get this impeller to move about 1 inch. We were having problems with my propane tank, so I switched over to Oxy and I was able to get this to move about 1 inch. So much so that when I look down on the shaft, I can tell that it is pretty galled up, which is why this is pretty difficult to remove. Now we did break a chain in the previous pull. I went ahead and called McMaster Car up and ordered some proper chain. This is 5/8 grade 100 with some eye hooks that go on the chain. The previous chain was not lifting rated and it was 3/8 no name brand. I remade these brackets or modified them to interface with the chain, which should eliminate the eye bolts being a weak point. And then we redesigned this back cap where the chain comes over to the hydraulic ram, and I made that out of solid 1.5 inch round bar. But I think the key here is heat. So I'm gonna go slow, I'm gonna warm this up maybe 600-700 degrees with the oxy torch, and then and only then we'll apply some hydraulic power and see where we go. Let's put some tension on it. .600 PSI out of 10,000 on the 30 ton. All right, that's a weld breaking over there. All right, that failed. All right, we'll come back when we have some results. All right, we're back on day 4 and we're on the 5th setup. And we're not taking no for an answer today. So this setup is radically different than anything we've tried, and I believe it to be overkill. We're gonna see if that is the case. So in terms of heat, we tried the propane. I ordered a different regulator. It's still freezing up. The reality is I think I'm pushing too much volume out of the tank, even on low, and it's freezing up the propane. I do have 2 large oxy tanks. I have one set up on a tripod on that side with a number 8 nozzle. I'm gonna come around to this side with a number 10. We're gonna get this thing as hot as possible. In terms of pressing, we've switched from that 30 ton to the 100 ton. As far as the pressing arrangement, we've switched out the 1/2 inch pressure plates for 1 inch. Now those really don't need to be bigger, more so it's for clearance because they're in compression, and we've opted out for threaded holes in the plate for nuts. We switched from chain to threaded rod, and we switched from our original 3/4 10 threaded rod to 1 3/8 6. And for our pushing plate, we have a piece of 2 1/4 inch solid 14-inch diameter with a hole recessed for the jack, and we also have a locating cap for the front to protect the threads. It's moving. $200,000. All right, we're right at the end of our travel. We pretty much got it. Yeah, it doesn't take much here at the end. All right, we're at the end of our travel again. This is nice about the screws here. We can adjust this pretty quickly. Here's a closer look at the shaft, and this is really bad, guys. I'm fairly certain that this material is a magnetic stainless, but I'm gonna get confirmation based on the customer. We did take a hardness check and we're around 30 Rockwell C, so this is a hardened shaft, and this damage is really excessive. Yep, I think this will work. I like this method because it doesn't damage the key because it's smooth. I think the galling is keeping this in on this other side. It is coming. There she is. Now I realize we're not going to be able to take this off till we address this, at least temporarily. So we're gonna wait to see what the customer wants to do before we get this guy off. We'll set this guy aside and we'll get the other one to this same point. Here's a close-up of the impeller, and you can see just how badly damaged and galled it is. Now, we heard back from the customer, and this impeller is indeed cast stainless steel, and the shaft itself is also stainless steel, and stainless steel on stainless steel does have a tendency to gall. Now, we also learned that this is actually a clearance fit or a slip fit onto the shaft of 1 thou. So technically speaking, when this was installed, it should have just slid on the shaft with very minimal effort, and there shouldn't have been any galling created by that. However, if they put it on the shaft with a lot of force, or there was debris that got caught in here when we pulled it off, that basically either exacerbated the issue or revealed the galling that was there when it was pressed together. The customer wants to basically clean up the shafts, clean up the impellers, put everything back together, and call it done. And I know that there is, liability, there's risk, there's a lot of things to weigh, and we went back and forth on it. And ultimately, because it is a short-term solution, because these are only going into service for a couple months, supposedly, and the customer is aware that there's no guarantee on this work from his end to the customer and my end to him, that is the method they are going to choose, and he is confident that it'll be completely fine. The impellers spin at about 600 RPMs, and they are attached or secured with a nut, and basically the goal is to remove all the high spots from the galling on the shaft and the impellers, get it back together, get that screw on there or nut. Here's a closer shot of some wear on these center discs. Now, these center discs are actually housings. The housings in the center have water passages, and they allow water to pass from one stage of the pump to the other. Originally, we were going to get all this together and assembled and send it out for balancing, but the customer learned that there were some seals here and on the inside, so we're actually going to get everything machined and send them back to him unassembled so that they can service all these seals with whatever methods they want. But for the most part, this is a two-part assembly, and the impellers, as you can see, have worn into the face. And so when these are rebuilt, traditionally what happens is they machine this face flat, so that way the base of the impeller can sit flat on this center housing. So our job is to come in here and just face this material only until it cleans up. The first step in doing this job is to make some custom vice jaws for our chuck on the lathe, so we can go ahead and grip this from the OD. For the jaws, we're going to be using this 3 by 2 by 36 inch piece of 1018 cold rolled steel. We're going to be making 3, 12, maybe 11 3/4 inch long jaws. So we're going to start by getting this cut to length. We have our soft jaws made, and they turned out absolutely beautiful. I'm sorry I didn't show you guys a lot of footage. We made these on the CNC, and I was going to show you the last one, but I kind of got excited and just forgot to film it. So we basically cut these off at the saw, put them in the CNC machine, and we're able to do all of this work on the CNC. So this is the top, and here's a shot at the bottom. And I've test fit these and they are a really, really nice fit. And we're gonna come in here and just give this a face and then cut our slight radius while we're clamping inward to match the giant discs. Before we get the gap out, I'm just gonna clean up all these chips and get this area thoroughly cleaned, and then we can start by removing those bolts. Wow, some tight bolts. Need to get a 3/4 inch ratchet. We need to take these 2 flathead screw caps out. I want to thank Josh Topper for giving me the advice on how to remove this. You would think it would be pretty obvious, but actually there are some taper pins in here that can be a pain to remove unless you use the right technique, and he was able to give me that so we can save time and not fight this. So to remove this dowel pin, we're going to take a threaded rod, I believe it's M8 125, get it in the top of that dowel pin, and we'll take a nut. And I should probably use a wrench. We'll use this wrench to pull this pin out. Ooh, that thing is tight. That was probably it, huh? Man, that was tight. Look at that. There you go. It was in there pretty good. All right, we're gonna do the same thing on the back. This one in the back is a bit different. We're gonna need to use some spacers. Is that it? There it is. Ideally, we'd be pulling straight up, but I'm gonna see if I can do this without removing the chuck. All right, I see what's going on here. So there's a cover here, and under that cover is 2 bolts that push the gap this way. Never seen that before. Also never taken out a gap. So learning experience. I'm guessing those bolts help tighten up this line so that there's tons of pressure together, and there's also alignment dowel pins and pressure down. Never seen that before, but we learned. We're going to remove this cover. I think we can get in there and loosen those bolts, and then it should come right out. They're like jacking nuts or bolts, I guess. Oh, there's another screw on it. Another tight bolt. There we go. That should take the pressure off at least one side. Look at that, popped right up. All right, let's see if we can get to this other one. There we go. That's it. Should lift right out now. There it is. Comes right out. I know we're not lifting directly in the center, but it'll have to work. There we go. It's actually not that heavy. Not as heavy as I thought it'd be. Here's a better look at those bolts on the back. Kind of a clever idea. I just didn't know they were there. Basically, they come back when they loosen, put pressure on the casting, and push this over, which is kind of a cool idea, I guess. All right, we'll set this off to the side and get our soft jaws in. Looks like the screws I ordered weren't long enough. It's the next day and we went ahead and solved some of our problems from yesterday. So the main issue that I noticed when installing these vice jaws was that the screws that I ordered were too short. Jumped on McMaster-Carr, ordered the correct length, ready for pickup in an hour, and was getting ready to go get them when I realized that the distance between the jaw and this gap was too tight. The part that we have to machine is around 4 inches, and this was like 3.5 or 3.25. And so even with the correct screws, we would not have been able to fit the part in this location. So I went to the drawing board in the CAM software, and it did take me a little bit because I'm still learning, but I was able to modify the Fusion 360 design and also modify the CAM profile so we could put these back in the CNC and recut them. And we took 3/4 off of every surface, including the counterbore, which meant that ironically the screws that I ordered, which were too short, are actually perfect. So that worked out quite well. But we messed with that yesterday, and today we're back. We're on the quick change tool post. Everything is locked down. Everything should be relatively rigid. So we'll come in here. We'll start from the center. I already found our 26-inch mark. So we're going to cut these a little undersized slightly. Let's go with 200 RPM. Feed rate 5C. Taking like an 1/8 off. It's too much. Let's come back to 50 thou. Clean it up fairly good. I realized that my jaws were nowhere near straight, so we're just trying to clean up the unevenness, which requires about 1/8 of an inch of material to be removed, unfortunately. I'm gonna lock my carriage because it kind of looks like it's migrating on me. We're ready for the first part. This took a little bit longer than I expected, as typical, but the jaws turned out pretty nice. We stoned all the corners, so there should be no high spots. Let's get our first workpiece up in the jaws. We're finally ready to get the machining done. It seems like it's been a long time coming, but there was a lot of stuff I needed to do in preparation to get to this point. I did throw an indicator on here to see how bad this is running out, and it looks to be about within 1 thou or 2, which is really good based on the diameter, but there is a low spot, probably this large, where it dips about 10 thousandths. Now we also need to machine a center spacer and adjust it for the amount of material we machine off. So once this cleans up, I will write down how much we took off, and we will add that to the other end cap, and then we'll also add up the amount we take off the center section, and that combined number will be what we remove on the spacer. So other than that, let's get in here and get going. One other note, this is actually off center. So we have just enough travel to do this job, because when it's off center in the other direction and we run the cross slide all the way back, it actually bottoms out right there, which is like 1/4 inch, and it only comes past like 1/4 inch. All right, we're running 125 RPM. The feed rate is 13 thou per rev. Just gonna come out here in the center and touch off. That's gonna be our 0. There we go, that's max travel. I'm gonna start out with 20 thousandths. Actually, you know what? I'm gonna change my mind. Let's do 30. I don't want to be able to create a chip here. So we're gonna take 30 off. Because realistically, with the highs and lows, it's probably not gonna be 20. It might be like 15 or 10. All right, I think 30 is gonna clean it up. I think it's gonna more than clean it up, to be honest. I think in one pass we can get it taken care of. Step it down to 80 RPM. We are switching to a different insert and a different head. I don't have a DNMG insert selection in the 600 series, so we're switching to a 400 series, and I do have a cast iron insert. This is not bad, but I think there's some chatter in there we can eliminate. So, seeing if we can have some success with a different insert. Speeds and feeds, honestly, kind of afraid to run it super fast, but I think the best finish I got was running it fast, ironically. Doesn't seem to matter, it just kind of vibrates. So we'll give this a shot, see if it makes a difference. We took 30 thou. We're also gonna take a lighter cut this time. All right, there we go, we're touched off. Zero it. We're gonna take 10 thou. Currently we're running at 250 RPM, feed rate, 12 thou. See if our finish is any better. I think it is. All right. In case anyone is curious, this is the inserts we're using. It's a Kyocera DNMG 150404 kg, and it's a 431 size, and it's for cast iron. And that's kind of what they look like. Seems to be doing good. I'm not hearing any chatter. I am, however, getting sprayed with cast iron right now. We just got this cut finished out, and I am really, really happy with how this turned out. I expected some chatter. There still is some very mild lining, but overall, this is a really nice finish, very consistent, and certainly for what it's being used for, I think it'll be more than adequate. So I'm gonna get this out of this chuck here, and we got 4 more of these to do. I'm not going to show you those. It's going to be more of the same with this. Another good reason for a large chuck key. We got all 4 of these done and they turned out really, really good. I'm very impressed with the surface finish considering what we're dealing with. Next step is to start on these 2 washers. We do need to face both sides, and I'm curious to see, they are quite a bit heavier. These maybe are 80 pounds each. These are probably 250. And they do have a hollow section on the inside. So maybe they're going to ring like a bell. Maybe that extra mass will help sort of deaden the sound. We're going to find out. Let's go ahead and get those in the lathe and get started facing one side. All right, this is much of the same. We're gonna touch off. We're gonna figure out how much we need to take off. And we stepped the RPM down. I know this is gonna bother some of you guys, but the last ones I was running at 250 RPM. That was the best to dampen vibration. Went slower, was worse. Went faster, obviously it was sketchy. 250, with that being a thin part, worked out really good. This part, obviously 250 is way too fast just because of the diameter. We're gonna step it down to 160, might be a little fast. We're gonna try it. With this type of stuff, you don't wanna be dangerous, but also it depends on the harmonics of the part. And some RPMs work better, some feed rates work better, so we're gonna experiment and kind of go from there. So we're currently at 160. All right, so we're gonna do what we did on the other one, which was we're gonna take 30 thousandths to start. See how it does. I have no idea how it's gonna do. So far, no chatter. Everything seems to be par for the course. A little bit of chatter right here at the end. Nothing too crazy though. Let's take an inspection and see how we did. Yeah, honestly, that looks really good. But what we're gonna do, and what I've been doing, is I take a roughing pass, I change the insert, and then we take a finish pass of like 10 thou. But I think that did better than the other ring in terms of vibration. Minus 32, okay. Loosen our carriage. Thought I would never need these. I've never used these on any other machine, but they are useful. We're going to change this insert out and make a finishing pass. We switched from the cast iron insert to using these. These are a Coralloy DNMG 150404 VB. The cast iron inserts did actually give a better finish, but with the interrupted cut, the edge broke down just a little bit, enough to where we got some vibration in the cut. So these inserts are a general steel insert. It's a CVD coated insert, but they can be used on cast iron. They maybe give us maybe 5–10% not as good of a finish, but they do hold up better. But what we have been doing is we rough this out with one face, then we'll flip it over to a clean edge and take a finish cut, and that'll give us the best finish, kind of the best of both worlds. That is a little bit wasteful on these inserts because they could keep cutting for a while, but with the cost of this job and we're trying to get the best surface finish, it's kind of negligible for the result. So we'll go ahead and get this thing flipped over to a clean side and finish out our cut. On the last pass, we ran into a little bit of an issue. Towards the edge of the cut, we were getting some chatter. It only had about an inch to go. I let it finish out, and overall for a roughing pass, this roughing pass looks just as good as the finish passes on the other one. So I think this ring is doing well. But after closer inspection, the reason we got some chatter here on the end is because these two plates started to separate. And it may not be obvious by looking at it, but this is actually two pieces pressed together. Now, I wasn't aware of that when we started, figured that out throughout the process, and the customer was also not aware of that. So a week or two ago, when he figured out that these were two plates, he decided to not have me reassemble this and balance this and give him back a full assembly, but rather continue with the job we were going to do, which was getting these plates faced, and go ahead and give him all of the parts unassembled, and their guys would pull these apart, replace the gasket here, replace this rope seal, reassemble it, and balance it in-house. No problem, business as usual. So when we went to chuck these up, I was aware that they were two parts. However, I was also under the impression that they're a press fit, and if this is anything like anything else on this, it's pretty tight. And so the first little bit, I didn't even think about it, to be honest, and towards the end, this did start to separate. So I could have chanced it. I think it might be fine because I think it is a press fit. Didn't pop off, but the seam just kind of opened up a little bit, and I'm not really too comfortable with that since we're spinning this, 250-pound large diameter piece. So we went ahead and came up with an idea. Might be genius, might be a terrible idea, but we fabbed up some brackets. I just milled out some square bar, and these brackets have a lip on this, so they grab on this lip. So it'll push these together. They're not going to interfere with when we flip these around in the jaw to do the other side, and they're nice and low profile, so as this spins, they won't pop off. And then as an added measure, I knew when I was clamping this, and because I didn't engineer this super precision, there would be slop in the bolt, which would cause this to kick down and want to pop out. So I went ahead and put some banding on this, and I also put a washer in the center, because these, when you tighten them with the slop and the screw, they want to come like this. So if I preload them up a little bit, they kind of level out, which they do. So with the strapping and with this should be nice and tight. And that is important because not only are we going to machine this side referenced off this, it's also going to give us a better finish and, more importantly, keep it nice and safe. So we'll come in here and we'll take our finish pass on that last side, and then when we flip it over, business as usual. On the next one, I will go ahead and install this on the ground, which will be a lot easier. Was a lot of fussing around to get this set up here, and then we'll just continue on. All right, here we go, round two, finishing pass. 43 thousandths total, so another 13 thou. Well, guys, that is absolutely perfect. Wow, couldn't be happier. I don't know if it's physically possible to get a better surface finish on cast iron. Our clamps worked well, perfect. I'm gonna traverse the carriage back and get this flipped around, and we'll start on the other side. It's always nice when a plan comes together. nice and flat. All right, second side. And there we go, we're gonna zero right there. This side has an excessive amount of wear. This is probably the most worn one. I think it has maybe a 1/16 of an inch. We're gonna start with 40 thousandths, and we'll probably rapid over to this point once we cut through that. Take another 40. All right, we got one disc done. We got both of these discs done and they turned out fabulous. The surface finish is excellent and overall they cleaned up really nice. The new lathe did an amazing job and I'm very happy about that. The one con with a job like this is how messy it can be. I am covered in cast iron and the machine is covered in cast iron dust, and that can be pretty harmful for the machine. So I need to go over there and get it properly cleaned up before we move on and do any more machining. We did finish out the other 4 discs as well. So what I'm gonna do is get these sprayed down with some anti-corrosive rust inhibitor, and I'll get them packaged up with their respective discs, and we'll put them to the side so we can start on the second phase of this job, which is going to be repairing the impellers and shafts that are severely damaged.